All right, so let's go ahead and look at the least common multiples topic. But actually, I should have finished the last video with this idea relatively prime. So we know if number is prime, it only has a factor one in itself. But there's this cool idea of something being relatively prime. So if the greatest common factor between two numbers is equal to one, that means nothing goes into it, then we say those two numbers are relatively prime. They're prime relative to each other because there's no factors. Doesn't mean both numbers are prime. They might be prime, they might be composite. One might be prime, they're not. But this idea that they're connected together, right? Like 4 and 5 are relatively prime. Can you come up with some others? Now, when we think about relatively prime, right, because we're still thinking about factors, another one is like 15 and 28 equals 1, the GFC. So 15 and 20 are relatively prime. Important reason why this is, we would know when two numbers are relatively prime, we know, like for fractions, we know as a fraction it's in simplified form. There's nothing else can go into it. So that's a nice little application for relatively prime, but it's also nice, a cool number curiosity around that. So we have this idea of numbers being relatively prime. We now go on to look at multiples. Now, multiples are the result of multiplying two numbers together, right? A product. When a whole number is multiplied by another whole number, with the exception of zero, the resulting products are called multiples. Almost like multiply, right? It's not the multiplier, it's a multiple. That's the answer you get when you multiply two numbers. Products, right? But the multiples, and you'll see a short list. These are all multiples of 2, 3, 8, 10. You can go through fives. It's cool for you to know your multiples, right? And so looking at 2 and 3, you will see that they have a lot of common multiples, but there is one least common multiple. In that case, it would be 6. Notice how we kind of jump. It reminds us of that problem earlier about starting at noon and then coming every 12 and 15 minutes. You can see in a visual how that looks. And at some point, they intersect with each other. That would be a common multiple. So numbers have a lot of common multiples, but there's only one least common multiple. So the least common multiple of 2 and 3 is 6, as we think about that. We have notation for that, least common multiple, LCM of A and B, right? We could use a set intersection method, meaning that once you have the numbers, just list everything out. You have a full list. I know it could be long, especially if there's not a common right away. So when we continue to list it, at some point we should have something in common, and the first one in common is the least common multiple. So for that one, we have 270. So that's a straightforward technique, especially when teaching young children with smaller numbers. You would use listed out. More advanced technique would be the prime factorization method. The steps are here. I'm not going to read those steps. But we end up taking the largest exponent that appears on it in the prime factorization when we look for the common, and we look at the repeated factors, right? So let's take a look at these two examples that are been done for us already been mapped out, right? So in looking at this here, there's 9 and 12. I see the prime product of primes. Now I'm looking for the largest exponents of the factors. So in this case, the least common multiple, right, of 9 and 12. I look, they both have 3. Which one has the largest one? So I would take 3 in this case. And then I see, okay, it has a 2 squared. There's no 2 in the other one, so I'm going to take the 2 squared, or 4. Sorry, I need a 3 squared and the 2 squared, not a 3. The largest one. So this would give me 36. The largest, least common multiple is 36. That's the first time they intersect with each other when you count it by 9s and 12s. Next, we would look at the least common multiple of 90. So bigger numbers, 90 and 630. Well, let's write it out. 90 and 630. And again, I want to point to, again, the textbook having potentially a little bit more explanation. So you want to go ahead and take a look at, right, the textbook as you go through them and look at that. So we're going to end up seeing in this case the least common multiple is 630. But let's go ahead and go back. I just want to remind you again of the textbook here as we get through that. And so in this case, the least common multiple, we look and see, okay, 2 is a factor. So what's the largest one? It's 2. They have a 3 squared, so you take a 3 squared. 5, they both have 5 to the power 1, so you take the 5. And then there's a 7, and the largest exponent 7 to the 1, so it's 7. So it actually then turns out to be, in this case, 630 turns out to be the least common multiple. Just happens that way, that it's actually one of the numbers that doesn't always happen that way. If it was 9 and 12, we got 36. 36. It wasn't one of them. So again, it could happen that way. And then lastly, before we do some other kind of cool stuff, one other way that I really like is the visual part, and I do have a little short audio component here where I explain a little bit of it better. You could play that there, me explaining this, kind of the power of this one, but you will see it's not a traditional way of looking at it, right? But when looking at this here, a visual way to see it, you draw it out, and then you look at the common factors, looking at 45 and 60. And then you have the remaining factors that are not part of the common factors. And then when you look at it, you will see the greatest common factor is going to be here in the yellow part. That's 15. And to get the least common multiple, what you do is you just multiply all of this across, and then you have the least common multiple. That doesn't seem right. 180. It should be 180, not 118. So when we do 3, let's do the math, right? 3 times 15 is 45. 45 times 4. And so this should be 180 because 45 times 4. So you end up with, in that case up here, this one would be 3 times 5. And here would be 3 times 3 times 5 times 2 squared. And there's your 180 because that's 45 times 4. Yeah, so that's how you would find it. So it's kind of cool. I'll let you just pull this one here. So based off of this and already done, you could pause and double check it. But the greatest common factor would be 6 because 2 times 3. The least common multiple would be 2 squared times 2 times 3 times 3 squared. So the least common multiple of 24 and 54 would be 8 times, so we get 2 squared is 4 times 2. So this is 8 times 27. So I can do that. That's 160 plus 56. So that's 216. So the least common multiple of 24 and 54 is 216. Double check my math, right? 8 times 27. Yeah, 216. I got that right. And then before we leave, there's just some cool number theory here. Go ahead, again, some things that just emerge through exploration and numbers. And so we have this is true. The greatest common factor and the times the least common multiple of two numbers is always the product. That was kind of true. And then this idea of how many primes are there. There's an infinite amount of primes, right? That's a cool thing. And then lastly, we end, and again, this is something you wouldn't teach your students, but it'll be a question your students ask you, which is, how many factors does a number have? And so what we do is, amazingly, we do a prime factorization. So 144, how many numbers go into 144? Well, do its prime factorization, get it, and then this complex looking formula here, all it says is take the exponents of the prime factorization, add 1 to them, and multiply, and that tells you how many factors you have. 144 has 15 factors. Kind of cool. Go ahead and try with another one. Of course, you have homework to try, and then there's also our math educator that we've follow on YouTube. He has kind of some other cool ways to think about it. That's it.